Advocates say that these techniques aren't just a get-out-of-jail-free card on the climate. They argue that they're likely to be necessary no matter what else we do, because the amount of warming that the world will experience depends on the total accumulation of CO2 in the atmosphere. That means that even if we drastically cut our emissions right now, warming will continue well into the future. And if we don't get our act together on emissions very soon, the use of these techniques may be necessary sooner rather than later. Be that as it may, critics of geoengineering, and there are a lot of them, have several complaints about this strategy. The first is, it's a form of avoiding the hard choices we have to make with regard to carbon emissions, a sort of technological solutionism in which we avoid dealing with our problems because we think some new technology will come along in the future to save us. More practically, they question whether it will reduce the urgency of the need to cut emissions if the public thinks that there is an easy fix right around the corner. The other problem has to do with how easy that easy fix really is. If we've learned one thing from the study of systems in the environment, it's that nature is rarely simple. As we've seen, ecosystems are composed of many complex, interacting elements. And it's not preposterous to think that making changes to the atmosphere or to the oceans of the magnitude that would be required to offset global climate change could produce some side effects. For example, solar radiation management requires the spraying of sulfate aerosols into the upper atmosphere. There are two major consequences that could occur from that. One is the formation of sulfuric acid as the aerosols combine with water in the atmosphere and precipitate back down to Earth in the form of acid rain, which can have serious consequences for both terrestrial and aquatic ecosystems. The other is that sulfate aerosols are known to destroy ozone and could contribute to the destruction of the ozone layer. How much acid rain? How much ozone layer damage would this do? It's hard to say, because no one's ever tried anything like this before. And that's part of what makes people deeply suspicious, the fact that there's this uncertainty surrounding the effects. And it's not just conspiracy theorists. Personally, I'm very sympathetic to the idea that people would be uncomfortable with this. Spraying chemicals into the atmosphere to change the climate sounds like something that the Joker from Batman or a James Bond villain would do. Coupled with this is the well-documented failure of scientists to always do the best job of communicating with regular folks. A recent experimental trial called SPICE in the UK was recently cancelled due to public outcry. This experiment was going to use a blimp to pump water vapor into the stratosphere. Now, even though it was just water vapor that was being pumped, people got really excited about it. Maybe, they thought, it's just water vapor this time, but it's going to be scary chemicals next time. And because the scientists hadn't done a good job of letting people know what was going on, some people saw this as a secret plan that had been uncovered at the last minute, and the trial was eventually shut down due to the outcry. The final critique of geoengineering is the question of who gets to do it. What if a low-lying nation somewhere that's really threatened by rising sea levels decides that since the rest of the world isn't doing anything about carbon emissions, they're going to take it upon themselves to start doing geoengineering, sending up their own stratosphere rockets? Would the rest of the world be okay with that? Probably not. But it's a good question. Who decides? Who does the experiments? Who deploys the technology? And what kind of agreement is needed among the nations of the world to pull something like this off? Geoengineering interventions are global by design, so we're all stakeholders in the system. And what if someone decides to take it upon themselves to just do it, to go rogue and run their own experiment? Well, it already happened with a carbon dioxide removal experiment in the Pacific Northwest. A researcher got permission from some First Nations peoples in a coastal area of Canada to sail off the shore and dump iron filings off of the back of his boat. And what he created was a giant algal bloom, just as theory predicted, and it sucked up all sorts of carbon dioxide. And you can see that here in the picture. So it worked. But it also created a bloom of toxic microorganisms, similar to a red tide, and that's a negative side effect of this sort of intervention. It also got the scientific community really mad at him, and it was decried as unethical because he didn't tell anyone he was going to do it. And the experiment was conducted without the monitoring standards that you would usually deploy for an experiment of this magnitude. And his defense was, well, the world is standing idly by. Climate change is happening, and no one else is doing anything about it. So I had to do something. I was right to do it. This was kind of a wake-up call to the scientific community. And there's a lot of debate right now about how to manage situations like this in the future. And it's a very tough question. How do you engage stakeholders in the decision-making process when the stakeholders are everybody?